Hello guys, in this video we will be making an inline 4-cylinder assembly as you can see on the screen. We will be using Freecad version 1.1 and we will be using the assembly module to simulate the workings of the engine. I will show you the final outcome. So if we press on select assembly and run the simulation and choose, I will set some numbers and let's try this. See the crankshaft is rotating and all the pistons and the related assemblies are rotating with it. So we will try to make this. So we will start by creating the piston. The first step is to create a part. We will rename it to piston. And inside the part we need to create a body, and inside the body we need a sketch. So we'll sketch in the XZ plane. Now we cannot just create the piston on our own measurements. We need some kind of specifications. For that we will use this PDF. You can find similar ones if you just do a simple Google search. So as you can see, we have some measurements here. So we will basically follow few of this, not a perfect number to number, but something we can work with. Here I am creating a rough sketch of the piston from one of its sides. So we have three rings, two compression rings and one oil ring. The oil ring is fairly bigger than the other two. So from this figure we will draw the model. In order to make the actual sketch, we will be using the polyline tool inside Freecad. We are not going to follow proper measurements. We will be just creating the basic outline. After that, we will put the correct dimensions and constraints in a later stage. Just make sure to get the basic outline. Next we have to make the line straight. So for that we will use the horizontal and vertical constraints. They both have shortcuts H and V, H for horizontal and V for vertical. So if we select the lines and either choose the option from the menu or press H or V, we will get the correct straight lines. Here we are doing the same for all the imperfect lines. A way to distinguish between these imperfect lines and straight lines is to see that the straight lines have a marking on their sides. Now we are going to use the dimension tool to add different dimension constraints to each of the lines and points. So let's start with the actual radius of the piston. Let's put that to 48 millimeters. Then each of the compression rings will have a height of 2 millimeters and a depth of 1.5 millimeters, and the oil rings will have 3 millimeters of height. The inner radius of the piston is 42 millimeters. The distance from the top of the piston to the first compression ring is 1.5 millimeters, so we will also put that. So for this lines we have repetitions here, and since all the rings have same depth, we can use the equal constraint as we see here. So we select these two lines and press on equal constraint and it becomes equal in terms of depth. And we do the same for this line in the bottom as well. Okay, so the depths have been constrained. Now we need to constrain the uh, height of these rings. So this one is 2 millimeter, and this oil ring is 3. The height between the oil ring and the compression ring is 3 millimeters. Okay, so the rings have been constrained. The next step is to constrain the depth of the top of the piston. So the distance is 12 millimeter. The next one is the overall height of the piston. It will be 80 millimeters. So this point to this point will be 80. Okay. To make our further stuff easy, we will somehow like link this sketch to some kind of point in the origin. So let's constrain that one too. So the distance between this line and the X line should be 80. So we have something like this. So if we need to make some changes like making a hole here, we can just use this line as the reference point. So it's completely constrained. We close the sketch. Now comes the interesting part. So we will press on the sketch and click on revolute or revolve constraint, revolve feature. So we will use the default parameters and press on OK. So as you can see, we got the basic piston layout, and you can see all the rings here, 2 compression rings and 1 oil ring. The next step is to create this gudgeon pinhole and this cavity in the piston. So it's a two-step process. The first step uh, we will create this hole and this structure, and in the second step we will create another circle inside this uh, hole to make some kind of what do we call extrusion to make the model more realistic. So we'll head over to Freecad. We will create a new sketch in the XZ plane. For time being, we will set the draw style to wireframe for better visibility. So we'll create a new circle, center on the Y plane, and put the radius diameter to 26 millimeters. Then the constraint will be constrained to the X line. Next, we will give a dimension to the X axis by 40 millimeters. As you see in this image, we need this gravity, so we will create that. We will use the rounded rectangle feature of Freecad to do this. Let's make some arbitrary rectangle and we will constrain it later. So put roundedness of 5. Okay, so then we will put the dimensions. With the y line, it will have a constraint of 26 millimeters on the right side, and the same thing on the left side as well. Okay, so we will raise this thing a little bit upwards. Let's say 15, no, 16 millimeters. Okay, so that would be good. I think we should change this a little bit more. 28 would make it better. Okay, so let's close this one. As you can see, we have this structure here. Let's go back to normal rendering. and we will use the pocket tool, two-sided, no, symmetric to the axis. Let's increase the value to 50. See, the cavity is increasing, so we can increase this a little bit more. Okay, so you can see that the hole is created. We press on OK. See, the basic structure has been created. Next, we need another extrusion inside this gudgeon hole. We'll create that. But before that, we need to create another cavity along this side. That is to create this thing that we see over here. So I create a new sketch in the YZ plane. Let's put the draw style to uh, wireframe. Then we'll create a rectangle of width 3 millimeters and height 30. Then we will constrain it to the y-axis by 45 millimeters, and then the bottom portion of the rectangle to the x-axis by 25 millimeters. So it will be perfectly centered. Now we have to mirror this sketch in the opposite side. So you will simply select this and press Z and S, then select the axis, and it will be copied to the other side without doing all this stuff again. So let's close this one and again go to pocket. Let's put the view style to flat lines so we can see the stuff. Let's increase, put this to symmetric and less increases. So if we increase this, you can see the cavity being drawn out in the piston. Okay, so this is the limit. Okay, so let's put that. So we can see a cavity being created here. The next step is to create the extrusion that we talked about before. Let's create a data plane by using this circle as a reference. Again, we will create a sketch based on this plane. And let's create a circle anchored to origin for 21 millimeters. So that's the inner circle radius. Outer circle radius is same as that of the piston, 26 millimeters. So close that. Next, we will use this pad feature. Let's put that two-sided. So on one side, we will have 26 millimeters, and on the other side, on this side, we will have 1 millimeters, and this side, we have 26 millimeters. Okay. So as you can see, this kind of structure is formed. So we can temporarily hide this plane. We don't need to show that. Then we will select this pad and we will try to mirror this. So we need to mirror this along this plane. So that's the base XZ plane. Okay, so this is the final piston structure we have created. So we need to, if we want to make this look much better visually, we can add stuff like fillets and chamfers. So let's try that one. So we will add fillet to the cylinder this side. You can see that, and let's try to do that on the other surfaces as well. Right, so now you can see the fillet has been added. We can also add other structures and other features to this plane as well, but I'm not going to do that. So that's it. We have made the piston component. Next, we will make the piston pin, followed by crankshaft and all the other stuff.
So that's it for this video. We will continue in the next one.